So, with applications of similar triangles, it's the same thing that we did yesterday. We're still going to set up the proportions. We're still going to cross multiply and all that. The only difference is today we have to draw our own triangle. So let's look at number 1. So number 1 says a tree that's 24 feet casts a shadow that's 12 feet long. And then it tells me Brad is 6 feet tall. How long is Brad's shadow? So we've got two things happening. We have a tree. Okay. It tells me the tree is 24 feet tall. And it tells me that it casts a shadow that's 12 feet long. And then it tells me Brad is 6 feet tall. Well, we want to know how long is his shadow.
Isn't it 3 feet?
Okay, so we can finish our triangles.
Sorry. I didn't mean to ruin the entire problem.
Stop.
I just thought of that.
So then we want to set up our proportions. So we could say 24 over 12 equals 6 over x. You don't have to make it a tree and a person, but make it a triangle at least. Yeah. So then we cross multiply. So 24x equals
72.
You got it. Good. So then Brad's shadow is 3 what? Feet. Good. Good. So make sure you put your units. Questions. Alright, let's skip down to 6. So number 6 says triangle IJK and TUV are similar. The length of IJK are 40, 50, and 24. The length of the longest side of TUV is 275. What's the perimeter of TUV? What does perimeter mean? Around. Good. We want to add all the sides. So, first let's draw our triangles. So we've got IJK. And then we have TUV. So it tells me all the lengths of IJK. So I've got 40, 50, and 24. Okay. It doesn't matter. So then it tells me the length of the longest side of TUV is 275. What's the longest side of IJK? Yes. Good. So the 50. So wherever we put the longest side on JK is where we want to put the longest side on UV. So our longest side is down here at the bottom, and that's 275. So in order to find the perimeter, we have to find both of the missing sides. So we can just call one of them X and one of them Y. Any questions on drawing it? Or where 275 goes? Or why? Alright, so now we can set them up. So we can say X matches the 40. And then since I started with X, I need to start with 275. And it matches the 50. And then we can cross multiply. So 50x equals 11,000. So then if I divide by 50, x equals what?
220.
Good. 220. Yep. So we've got one side, but we still need to find that y. So we can set that equation up as y matches the 24. And then again, we can use the 275 and the 50. We can use the one we just found. It don't matter. You get the same answer. I'm going to say the 275 and the 50 just because it's probably what most of y'all will do, which is fine. Then again, we cross multiply. So 50y equals, and 275 times 24 is
6,600.
good. 6,600. So then if I divide by 50, what is y?
132.
Good. 132. So then if we want to find the perimeter, we add all threes up. So 220, 275, 132. So then our perimeter equals 627. Okay, so number 9 says Lucia began walking up a hill at a spot where the elevation is 0.9 kilometers. After she walked 3 kilometers, she saw a sign saying the elevation is 0.95. How far will she have walked when she reaches the elevation of 1.1? Draw a diagram. So here she is. She begins walking up a hill. Okay. So where she begins walking, the elevation. So elevation, you know, is your height. So where she begins walking, the elevation is 0.9. Okay. So then it says after she's walked 3 kilometers, so she's walked 3 kilometers, she finds that now the elevation is 0.95. So we want to know if she keeps on walking, how long does she need to walk? So we're looking for x when the elevation is 1.1. .95, yeah. Well, it said after she had walked 3 kilometers, it was 0.95. So in this one, it gives us 3 different things. But really, we just need to know 2 of them. So if I cut this off here to make my 2 triangles, okay, then what I'm doing is I'm cutting off 0.9. Everybody okay with that? Because that's our height. So we're cutting 0.9 off. So then I'm going to redraw it. Bless you. Let's redraw it over here. And so if we cut off this 0.95, or sorry, this 0.9, then that leaves us 0.05 for that one. Yes. And then that leaves us 0.2 for this one. Okay. And the only reason we have to do that is because she didn't start at the ground. And we have to make our triangles. And without cutting that off, we don't have nice triangles. Okay, but we know that she walked 3 meters here, but we don't know how much she walked here. That's what we're trying to find. Any questions on that? So now we can set it up. So in this one, we have the whole side is 0.2. And the whole side is 0.05. Okay. So now it's like one that we were doing earlier, so we need the whole side here. So this whole side is 3 plus x. Okay. So this whole side is 3 plus x, or x plus 3, don't matter, over, and then the whole side of the tiny one is 3. Okay, so again, it's whole side and whole side. Do what? Which one? The x plus 3? The 0.05?
I get the x plus 3.
Okay.
I don't get how you say that.
So I set it up, the whole side was 0.2. Then the whole side on the small one was 0.05. So then I'm looking at the big triangle here, so the whole side is x plus 3, and then in the small one, the whole side is 3. So again, if they look like this and it's easier for you, you can separate them into 2 different triangles and still set them up and get the same answer. So now if we cross multiply, we get 0.6 equals 0.05x plus 3. And then we can distribute. So we get 0.05x plus 0.6. Oh no. Sorry. 0.15. And then we can solve it. So subtract the 0.15. We're at 0.40. Do it the other way. 0.6 minus. No. 0.15 minus. And then we divide by 0.05. And so we get x equals 9. So she needs to walk another 9 kilometers is our units. Of course, that one was kind of strange. Okay.